here are the alternate examples from 3.1. It starts off pretty slow, right? We're going to do a lot of calculator work today. We're going to learn how to do this, enter this bivariate data into our calculator. So here we go. Tim wants to know if there's a relationship between height and weight. Kelly wants to know if she can predict the student's weight from his or her height. Information about height is easier to obtain than information about weight. Or rather, truthful information is easier to obtain about height than it is about weight. Okay. We could transform the data and add 10 pounds to every girl's weight. So that's probably closer to the truth. So let's see. For each student, identify explanatory and response variables. Okay, Tim. He wants to know, is there a relationship between height and weight? Well, Tim, what do you want? Is there a relationship between height and weight? Yeah, probably, but like, what do you want to know? Do you want to know, does height determine weight, or does weight determine height? There's not enough information there for us to name an explanatory and response variable, right? He wants to know if height if he wants to know if height determines weight, or weight determines height. It could go either way, right? If there's a relationship, you could have either one be the explanatory and the response variables. So, for this one, either height, or weight could be explanatory or response. All right, and Kelly. She wants to see if you can predict a student's weight from his or her height, right? In other words, does height determine weight? So that means then that, all right, this is the word right here, predict. Predict tells me that this is our response variable, right? Our response variable is always a prediction. It's never actual, right? Or I should say, when we do least squares regression, our response variable in that case is always going to be a prediction. Right? And so we'll be looking at position and y as being a prediction. So we would then say that height is the explanatory variable, and weight a lot of it. Neither comma there. All right. Oh yeah, that was really easy. Let's move on to something a little better. Here we go. Let's put some data in our calculators. Okay. So. Oh. You don't have one? What happened? All right, so let's put some bivariate data into our calculators. So whenever we're given raw data, we're always going to start with listen spreadsheet number 4. Hey, that's pretty good. All right. Okay, I need to look at the list again. Sorry that we're on double. All right, so let's name. First of all, let's figure out. We need to first figure out what our explanatory and our response variables are. I wanted to get out the technology right away. They ran a 40-yard sprint and then did a long jump. Long jump? Long jump? A long jump with a running start. My eyes were on start when I said jump, so we keep jumping. The table shows sprint time in seconds and long jump time in inches. Wow. I'm not sure. All right, now that that's fixed, we want a relationship between sprint time and long jump distance. So, if we want to determine if sprint time, if we can predict long jump distance from sprint time, right? Then we'll go ahead and make our explanatory variables. There's going to be sprint time. Response will be long jump distance. All right, now if we were going to make this by hand, right, we'd have to draw our x and y axes, and we would have to determine some scale, right? We'd have to make some scale. Unfortunately, since we have these awesome calculators, it's going to scale it for us. So you don't really have to worry much about that. And furthermore, I'm sure that you all would choose the right scale. I'm confident, I should say. I'm confident that you all would choose the right scale. So let's go ahead and make this thing. All right. Sprint time, long jump. Let's call it. So let's call this sprint time.
What's your long jump?
Huh?
What's your 40 speed?
And this is, we'll just call this one jump. So there we go. Now we're going to have two lists. All right, we'll go ahead and enter that data now. And I'll do it alongside you as well. I have no idea how far I jump. I have no idea how much I bench, and I don't know how long it takes me to run 1 mile. So those are the most common things that are asked are, you scrum and how much you bench. I don't bench press stuff. I don't do that. I can currently do like for a mile. I do run, but I never run. I mean, lately I run 10Ks. That's like my distance. I haven't ran just a mile in years and years and years. It would be a waste of time for me. I would burn myself out on one workout. And I need to build it in. Huh? See what? Oh, canoeing? No, and when you're going down, when we go down rivers, so I'm just steering primarily. We'll paddle a little, but no, I'll not compare to no. I've never done that before. No, I swim. Just swim. I can swim about a minute 30 seconds for every 100 yards. That's pretty far. No, I swim, like, in a race, I'll swim anywhere from 1,000 to 1,600 meters.
Yeah, I think I know that.
Are you?
How many races do you do a year?
In 2018, I will have completed 5 races. I should have done 6. Okay, 5.4.1. 5.41. No, I take winter off. Yeah, and I'll just I'll train a little bit, just to keep it going.
Long jump distance and B.
Yeah, I would do that. 7.1, 6.63.
I'm definitely.
What up? Oh. 6.44. 6.25. Right, guys, and whenever I get done with a row or a column on me, I'll go through and count and make sure that my count matches his count. It's a good way to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should have 12. Good. So I know it's a good way to check if you missed any data. 490. Six, 5, 7, 8, 30.
One of these days I know it's so good. It's my favorite one to photograph too, because literally.
Yeah.
Like they. Yeah. Like everybody's faces are different and they're so like.
All right. So, it should look like this. Keep in mind, all right? Each one of these need to match, right? My sprints, I cannot mix up sprints and jump, right? These are ordered pairs. They belong together.
Right.
Somebody did, but it was all right, let's make a scatter plot. So let's hit dock. Insert. We want a data and statistics page.
Dot. Insert. Yes.
Now, we get to add variables to both x and y, right? So what did we say our explanatory variable was? Sprint, or our x-axis. What did we say our response variable was? Jump. So you'll click over here on your y-axis and choose jump. And there you go. Wow. Got a scatter plot. Yes. All right, so the problem, and I know it's really hard to see from where you are, is let's describe what the scatter plot in the previous example reveals about the relationship between sprint time and long jump distances in this statistic plot. So let's look at our graph again. And I'll say it, and then hopefully I'll remember it so you can write it since we're on a different screen. But remember, we want to describe, when we're asked to describe it, we want to talk about its form, direction, strength, and any extreme value. Okay. All right. So it appears to be there appears to be a moderately strong negative linear relationship between our explanatory variable spring and our response variable jump. Furthermore, there don't appear to be any extreme values. So that would be a 100% complete description of this relationship. Okay? Of the relationship between this particular explanatory and response variable. I'm going to write it down because I want to make sure that we are including all of these elements in our description. It is very important, just like socks. All right? So we would say there is a moderately strong. So this points to our strength linear. That's our form. Negative. And this is our direction. Relationship. There. Sorry. Let's see. There is a moderately strong linear negative relationship between springtime. We've already defined it as well. We've already explained what our explanatory and response variables are. I don't need to do it in this sentence necessarily. It's written right above it. Between springtime and long jump. I don't know why it's long. Alright, let's do Alright, so let's do it again. Let's go ahead and make a scatter plot of this data. And we want the relationship between the amount of sodium and amount of fats. Salad. Sorry, I'm just trying to contextualize. I'm always trying to contextualize this data. Before I begin, I want to try to let it sink in. What am I looking at? I'm looking at the salad. So can we determine the amount of fat? What is the relationship between sodium and fat, right? So let's go ahead and yeah, let's do that. So sodium will be our explanatory variable, fat will be our response variable. I'm going to go ahead and so what are we going to do? We're stuck here, right? Let's go home. Let's make a new document. Do we want to save it? Nah, I don't think we need it. Alright. We'll need a new list and spreadsheet. What's that? I think you typed the wrong thing. Something's going really strange here. That's better. Sodium? If you want to put salt, go ahead. Salt? Will someone please right now? Alright, and now I'll put this data up here for us so that we can iterate.
Did you really? You just.
$8.21 and 4.59. 4.5, darn it. It's looking like you want that side salad early. Huh? 4 is second to last, yes. Well, not perhaps, but that is statistics. Does anybody in here say data?
No, it's
Will it bother you that I say data?
data is for data. That's so true. Like data? Oh. Yes, wow. No, I swear we never found. Yeah.
And that's like real. That's like the official.
It's official. That's Did you hear?
I told you I'd have them done this exercise at the end of the day. I've only graded like 4.
Not
4. Okay, so you'll learn 4 data points is definitely not enough for me to make a prediction.
I think that we're all.
No, actually, they vary. There's a bit of variation in those scores. Hey, but it did make me think of having this conversation. I said you can retake the pre-response, and no, I didn't get any takers on chapter 1, so I was thinking, why not? And I thought, you know what, I didn't actually give you guys a time frame, and there is one. But for chapter 1, since it took me so long to get it back to you, you have a bit longer, but it's going to be before the next test, okay? So you want to get your free responses done before we take the next test. I'll go ahead and do chapter 1 and chapter 2 before we take the chapter 3 test, okay? So we can do both. So if you want to take free responses, you can retake them before the next chapter test, which won't be for next week. Huh? Nah, that's what the curves are doing. Yeah. No, that's going to be a requirement. Yeah, I'm gonna, you're gonna actually come in and we're gonna talk.
I took my
I love what you're right. I love what you. And then, after you understand what it was you did, what it is you did today, how's it going? Yeah.
Thank you so much. So cute.
Wait, so I can use on the name for $15.
Yeah, I'm getting those. Those are so cute.
You could make them 20 and then just pocket 5. Oh, that would be by, that's called embezzlement. I think that's very illegal. It's fraud. Please don't commit fraud.
I think that's sodium goes on the wall. Okay. Is that right?
It's not bad. It's not bad until we get off.
So what's it called? The sodium goes on the Y?
Yeah.
Oh yeah, that was
All right, so there we go. Gosh, looks like I forgot to hit pause while we had that pause to put in the data, but it makes for a long video. My computer is almost out. I do. I don't want to. It's an extra thing. I really don't need it. I don't need to add it. All right, so let's go ahead and insert AP data and statistics page. Then we determined already that we wanted sodium to be our explanatory variable, and we would like fat to be our response variable, and there we go. This one is much more interesting.
Wait, you said sodium goes on the Y. You just told me that.
Sorry, we had said, sodium explanatory fat response. We'd like to know if having more sodium kind of means that there's more fat in the salad. Alright.
So you told me wrong?
It's very easy to switch, I apologize.
Thank you for letting me run.
Yeah.
You lie.
Alright. Let's talk about this one, because this one's very interesting. It looks like there are 3 clusters, right? And this data appears to be non-linear because of this one cluster here. Right? If I was to draw a line, what line fits better? That one? Or that one?
Oh. I think. Yeah.
Well, but you have these 3 points that are serious departure from the pattern, right?
But we also still get it, even if we place.
Okay, but there is at least the distance on average from the line, right, is less for the nonlinear line than it is for the linear. Because of those
I was not ready for it.
because of these 3 points here, we definitely have a departure from a linear. All right. So there appears to be a fairly strong, positive, nonlinear relationship between sodium and fat. But what's weird is, if we looked at these clusters separately, right? So if I was just to graph this cluster, I would have a linear relationship, right? If I was just to graph this cluster and this cluster, those seem to have a linear relationship. So that's kind of weird. That is quite different. Let me see if there's a little more that I can say about that. Just because those clusters, the clusters are interesting to me. Yeah. Yeah, because if it's nonlinear and positive, it could go like that, right? With nonlinear and negative, it's going to go like that. You could also have, yeah, it could follow some sort of weird polynomial function, right? Where it's got some behavior like that, possibly. Nonlinear. So it's simple. You don't have to. The cool thing is you don't have to figure out is this some like third degree polynomial or something like that. You don't have to do that. It's either linear or something. So that makes it a little. As we go on, we'll figure out. But we'll mostly be dealing with exponential. So, and that's going to be at the very end of the year. We'll come back in that context. All right. Hey, here we go. Here's their interpretation of this.
Wait, why is that so different?
No. This is long jump sprint time.
Oh, I was
All right, this value of R, we have an R value of negative 0.84. We need to interpret it in context, okay? So, now we're not going to talk about there being an association or a relationship. We're going to actually use the word correlation, right? So based on the value, for A, based on that value, we can say that there is a moderately strong correlation between moderately strong, I apologize, negative correlation between sprint time and long jump distance. What's up? So if you don't have this number, you may not say correlation. Okay? If you, for instance, if you just have a graph, you can just describe the association. Or say there's a relationship, right? If you have that number, then you can say correlation. All right, this point right here. What do you think it's going to do to the correlation? Remember, okay, this R value, correlation, is between -1 and 1. Where an R value of 0 means there's really no correlation between your explanatory and your response variable. And R value of 1 means that there is a perfect correlation between your explanatory and response variable, but it's positive. And -1 means that there's definitely a perfect correlation between your explanatory and response, but that correlation is negative, right? Negative data. So this thing, right, is extreme, right? Or not extreme, but it's not fitting the pattern. It's out here. It's a little more positive, okay? So imagine if you had a least squares regression line like that, right?
Yes.
This point is pushing it up. Changing the slope. I don't know if we want to. So this is actually taking it away from a correlation of 1. So it's decreasing. This point should be decreasing your correlation, right? So it should be making it closer to 0. Okay? So decreasing your level of correlation, right? But your R value is actually increasing. It's already negative. You know what I'm saying? The R value is negative. So this is going to make, so this point makes the R value or the correlation closer to 0. Meaning that it's going to increase it, right? It's going to decrease your correlation, but it's going to increase that actual number, the actual R number. Yes, it will be higher, which means that there will be less correlation. Considering we started off with a negative number. And this is just an interesting example about comparing these two. I'm just going to leave it on the video. You can look at it.